Live, and here we are, Simonetta. I thought at the beginning to do it in Italian, and then we say, oh, come on, let's do it in English. We are talking about space here, so
Absolutely.
full on, let's go in English. Also because, I mean, where are you at the moment?
Currently in Vienna, in Austria.
All right, so you live there?
Yeah, since beginning of 2014.
All right, since beginning of 2014, and so basically you are out of Italy the majority of your time. I can imagine.
Yeah. Also because I'm leading the Office for Outer Space Affairs, which is an office of the United Nations dealing with space activities, and we serve the 193 member states of the United Nations. So quite a broad, portfolio.
Right. So basically, I saw that. I don't know how do you spell this, because at the beginning I thought UNOSA. In Italian I would have said the UNOSA. You are at the head of UNOSA. UNOOSA. Do you have a way to spell it?
Yeah, UNOSA is the way in which we pronounce it. It is United Nations Office for Outer Space Affairs.
All right, so the UNOSA, and I saw that I think last week or 2-3 days ago, you came out with this gigantic annual report 2019, and so I started to read, and then I thought, oh my gosh, there are so many things. Are 88 pages, and you do so many things. So I was curious to understand more, about all the activities. First of all, for the people that doesn't know exactly what your office is doing, what's your main focus?
Well, first of all, every time we talk about the fact that the United Nations have a dedicated office dealing with space activities or outer space affairs, as we say, sounds a little bit strange. What the UN has to do with that, right? So in reality, the office was created in 1959. So started their activity in 59. At the time, it was the very beginning of the space era, in a way. And we had only two countries, Soviet Union on one side and the United States on the other side. Now we have more than 80 countries having a satellite or having had a satellite in orbit. We have more or less the same amount, 70 space agencies around the world. And we have more than 2,500 operational satellites in orbit. So what we do is to really try to bridge the space divide, which means that the difference between the spacefaring nations and the countries which still have to benefit from space. So our goal is to bring the benefits of space activities to everyone, everywhere, which means that we deal mainly with emerging and developing countries. I'm trying to train them in using space-based data and infrastructures to improve the quality of life of their own citizens. That's more or less, in a nutshell, what we do.
Wow, this was a very, very condensed version, because inside this report there are so many activities. By the way, about facilities, I was really intrigued by this. What's the name? Hypergravity. There is. I wanted to understand more, because from what I understand, you can you can use the facility. Of course, you have to submit your application and so on. So I imagine I will not be able to use your hypergravity facility, but I would love it.
Well, the facility is not ours. Is a facility of the European Space Agency located in the Netherlands, where ESA is one of the main locations in Europe. And we signed a memorandum of understanding a bit ago. And this is a centrifuge, in a way, and it's a system, it's a facility to test on ground experiments which have to go in microgravity, so in orbit. And we just announced recently the selection of the first team, because this is the first time, the first round of this, let's say, selection that we do together with the European Space Agency. And we selected the team from Thailand. We then support this team to come to Europe, to the ESA facility, and together with the European Space Agency, we train this team and we support the team for performing the experiments. And this will allow the country and the team to acquire a lot of knowledge and then be prepared for additional, let's say, to the next level experiments, eventually to be launched on the International Space Station or in orbit.
Got it. Got it. And the hypergravity is the one that
Yes, it's a
basically is like when
centrifuge,
you spin the salad. Is basically
exactly.
wow, that's be so fun. Anyway, but that's interesting. So basically, you try to bridge a lot. You
Correct.
bridge a lot between more advanced nations and nations that have
Correct.
to improve their space. There are a lot of questions immediately in the
Okay.
chat. Sometimes I'll just throw you some random questions. But first of all, I'm so passionate at the moment about a silly Netflix series, Space Force. Have you seen it? Oh my gosh!
Part of it. And
All
I
right.
have to say that is interesting. I mean, I'm in the middle, so it's interesting because there are some elements which are, let's say, real facts, real events, and then are transformed, and in a more not funny
way.
but yeah.
I don't know. I find it so funny, but I find it funny and interesting for several reasons. One reason is that sometimes they give you a lot of dumb, silly questions that users maybe have, or some, conspiracy theory, and then they have the answer of like a engineer working there, looking at them very quiet, saying, "No, this is not true. No, it doesn't work." Like so. But and obviously, I mean, Steve Carell and John Malkovich.
Well done. It's really well done. Yeah.
They're funny. I like it when the POTUS, president of the United States, is sending text messages saying, "No, now you have to do this and you have to do that." But also the way he has to approach things in a very, let's say, unskilled, unprepared way, and he's the general and he has to take decisions. I don't know. I find it very funny, but in a nice way. Like
no, it's there are a lot of these fictions or whatever related to space. Some of them are a little bit more close to reality, and others are really science fiction. For myself, I mean, I'm an astrophysicist by education. I've been working in the space field now for 35 years, unfortunately, which means that I'm getting older. And but it happens. And so in reality, I like more the, let's say, when a movie or fiction, I mean, a series is more close to reality. So with a bit of fiction, but more close to reality, because it gives you a bit of a, let's say, a flavor of what your future could be. But when it's too far away, then it's really too future. and so I don't like them so much. But it's just a question of taste.
Have you seen the bit when they send the satellite in the space and the Chinese destroy the satellite?
Not yet.
All right, in parts.
Don't
And I just tell you that they have to decide who to send, and he will do a very uncommon choice to decide. Among all the options he has, he chooses the worst one.
Okay, you are stimulating my curiosity, so I'll have a look.
Right. But I mean, starting from there, for instance, one question that come out immediately, I think at the beginning of the series is, why should you do something with the space? We have Earth here, we have problems here. Why humans, they have to go to the space? And sometimes you see that it's coming out this kind of question. So, for instance, I give you this question from YouTube. Wait, oh my gosh, this is really hard. Doitokatuki. Oh my gosh, Doitokatuki. I think he likes some manga. How can the emergent country can improve the lives of common citizens with this data? And the general question is why space matters, basically.
Yeah. Well, first of all, each of us, we use so many satellites per day that we don't even know. From the moment in which in the morning we check, for example, if today is going to rain or not. The information you get from a normal, one of the apps that you can find on your smartphone. In reality, they collect the data from a lot of meteorological satellites, and so what you get is the final result. So it just seems, easy, but in reality, is a lot of work, is big data, is machine learning, is a lot of also new technologies, new frontier technologies injected into the system. It's not only space-based data. And these satellites are developed mainly by few countries, just a bunch of countries which are able to develop advanced meteorological satellites, and then all the data are collected for the benefit of everyone, because you can be in a country wherever in the world, you don't need to have a satellite in orbit to get the information. The same, for example, if you use your navigator in your car. So you go from one place to another, and in order to do that, you need a constellation of satellites. And for example, what we do in this field is to bring together all the providers. So we have a sort of a coordination mechanism under our responsibility, where we put together the Chinese with the Beidou constellation, the Russians with GLONASS, the Europeans with Galileo, and the Americans with GPS. GPS is the most known, but all these are what we call global navigation satellite systems. Putting all them together, you have higher precision, which means that you can geolocate whatever you like, really with high precision. And also, this kind of data are absolutely free. And so in any country, you can train people to develop services and applications. So also a little bit of what we call the space economy on the downstream part, because you can create startups in small companies which can benefit of this data for improving, I don't know, agriculture, food and water security, biodiversity. I mean, there are a lot of fields in which telehealth and teleeducation. So there are a lot of fields in which space-based data are absolutely mandatory.
And they don't have all the startups to build all the infrastructure that would be impossible to be. One question, Simonetta, I wonder, how is it possible to coordinate countries that are so different, and so many times they are one against the other one, and so you have, you know, China, Russia, Europe, US. What do? You call them all and say, all right, guys, now everyone together, let's put the satellite together.
Well,
how does it work?
Well, let's say the convening power of the UN is really there to help the dialogue, to foster international cooperation, which is what we do, let's say, bread and butter. In the sense that we have also what we call the Committee on the Peaceful Uses of Outer Space, which is currently composed by 95 members. And
I lost you. The satellite is gone. Wait, are you back?
Okay. Yeah.
It's not the satellite. It's usually when a call is coming in, is going down sometimes. We're back.
Yeah, but and so we have everyone. We have China, the Russian Federation, United States, Canada, everyone. Europeans, as I said, 95. And the point is that the decisions are taken by consensus, which means that the process is long, because clearly they discuss every single word of a text to be approved. But when it's approved, everyone is committed, because they've been working a lot, and they, at the very end, find let's say, the compromise solution. Well, it's not easy. I cannot say it's easy, but it works quite well. And on top of that, we have these mechanisms like the one I was mentioning on GNSS, on Global Navigation Satellite Systems, where having this system interoperable allows to go for more precision, and therefore you can develop more applications and more services, because the data you get are more precise. For example, we have, I don't have now my watch, but for example, my Apple Watch is already receiving both GLONASS and GPS. So you have both systems, the Russian and the American. And so you have a better coverage of satellites, and therefore the information you get in terms of geolocation is more precise. If we are able, at a certain point in time, to have receivers collecting all the constellations, you have always between 6 and 7 satellites in coverage instead of the 4 you need, and therefore the precision is higher. And you can do, for example, precision farming, or you can better monitor, I don't know, in terms of when you have to recover, when you are in a recovery phase after a disaster, for example. So this kind of information are crucial to save lives and things like that.
Help us understand, Simonetta, about this topic. What kind of laws are for space? Because, for instance, you mentioned satellites. I spoke with the CEO of an Italian company that is producing satellites, and we saw SpaceX launching a lot of satellites recently. How does it work? I mean, everyone can do it. What are the laws? I mean, what's the situation for space?
But it's quite well structured. One of the activities that we do among the 80 pages of the annual report is that we in a way maintain the responsibility over the outer space treaty and the other treaties, plus a lot of principles and guidelines which have been developed during the years by the Committee on the Peaceful Uses of Outer Space, and in particular there is a subcommittee called Legal Subcommittee, which is in charge of the legal part. So the Outer Space Treaty, in a way, is the foundation for any activity in space, and it's clearly spelled out in the Outer Space Treaty that the country in which you have, for example, a private company developing, like in the case of SpaceX, 12,000 satellites for the Starlink constellation, or other companies, for example, in the United States, in order to be able to launch, they needed to get a license, which the relevant institution, the relevant entity in the United States of America will will approve only if the satellite or the constellation is in line with the treaties and the principles and guidelines that the United States of America approved. I mean, this is true for the United States, it's true for each country. Countries. And in addition to that, there is another important element from the legal standpoint, which is the registration convention, which means that each country as to, after the launch happened, they have to send us a notification where they say that they have launched X, Y, and Z satellite, informing us about the orbit and a lot of other parameters. And then we check and we put this information in an online register that you can find on our website. And so there is a full transparency on all the satellites which have been launched in space since the beginning of the space era, which is a sort of, is a tool that everyone can go on our website and consult, but at the same time is a way of maintaining this transparency and credibility between the various member states, so between the various space powers.
That's interesting, Simonetta. I didn't know there was a satellite registry. I will go to check who is in the space. What, but do you see only like the name of the satellite, the company?
And some information on the orbits and things like that. Yeah.
But what happens if technology is improving a lot, and a lot more companies are able to create something that potentially go into the space? How do you avoid like a space saturation with too many satellites, too many objects, and then you can't even see anything in the sky? So how do you block? How do you prevent that?
Well, this is one of the let's say the most trendy topics currently under discussion. On one side, you have to consider that the space sector is blooming really right now. So in the last few years, we have been witnessing a lot of new companies popping up, a strong interest on the commercial sector. And in reality, if you want to develop what we call a safe commercial space, we also need to have rules and regulations, what we call the rules of the road, so that everyone follow the rules, so to allow all the others to potentially utilize the space as a resource. This is extremely important, and in fact, more and more we talk about space traffic management. So a set of rules which have to put in place in order to allow let's say, I don't want to say coordination, but at least a full picture of what's going on in space. And this is also linked to what we call the long-term sustainability guidelines, which have been recently approved by the Committee on the Peaceful Uses of Outer Space, which help. They help the new players, but also the old one, but also the new players, to start their activities with a responsible behavior, because a responsible behavior for them is also, let's say, preventing the others from being in a difficult situation with their own assets in orbit. And in this sense, we have also dedicated programs for the new players, where we teach them in terms of, giving them information on the outer space treaty, the guidelines, and all the regulations, but also we give them a little bit of information about best practices and lessons learned from the past, also with the help of what we call the spacefaring nations. So the ones who have been in space so long that now they can also help us in bringing the new players at the table with the right approach.
And do you think that today there is less competition about the space between countries? Like at the beginning was like this space race and US go first or Russian and whatever. Is today more collaborative environment where countries try to go together, or there is still some kind of competition in...
Well, I've always been convinced that in order to cooperate, you need to have a bit of autonomy in technological terms. So in the sense that if you are a developing country or a country which wants to become a spacefaring country, so launching a satellite, etc. Yes, it has to be done in steps, because you cannot go from scratch to whatever. So it has to be done in steps. But the point is that if you don't have a bit of autonomy in terms of hardware development or how to better use space-based data, you cannot cooperate really, because there is no substantive matter for a cooperation. So the idea is that one of the areas one of the pillars under which we consider our activities is called space diplomacy. So the way in which we try to use, while bridging the space divide, we help also countries to improve their international relations, their bilateral relations. And so we always push for international cooperation in bilateral, trilateral, multilateral ways, because in this manner, by definition, you also elevate the knowledge in a lot of countries which really want to start activities in the space field, but they need also a bit of support. So it works quite well. One of the approaches that we use is what we call the triangular approach, where we are a sort of a broker, and we connect the dot between the developed and the developing countries. And in this manner, for sure, the developed countries, the spacefaring countries, help us, sometimes also with in-kind contributions, offering a slot for a flight or whatever, but also in terms of training. And in this mutual exchange, then the ecosystem progress.
Got it. I have a very funny question in the chat. I don't know if I can send it over to you. Yes, I will. Daniela Cancini asks, who is the moon's owner, for example? And I recently watched a movie, Unspeakable Me, through 2 or 3, I don't know, where there is the super buddy that say, I want to own the moon, So there is no owner of the moon at the moment.
Reading the Outer Space Treaty, space, and therefore the moon, is the province of humankind. In reality, in the Outer Space Treaty, it was mankind, but I always translated humankind, because mankind, allow me, it is a little bit considering only half of the population in the world. So I say humankind, which in my opinion is better.
Yeah. Great. Imagine if you say, well, I'm the owner of the moon starting yesterday. That would be a great news. Like, oh my God, it's all mine. But I see a lot of people worried in the chat about space garbage, how to avoid, that space become full of garbage. I don't know. There are several comments about that. What do you think? How do you prevent that with rules? But is there some kind of specific program for that?
Yeah. There are a certain number of guidelines approved a long time ago. And in particular, these guidelines are relevant to the fact that satellites have to be built in a way that then at the end of their life, they can be brought back on Earth, because when they re-enter the atmosphere, they're burned. So it's not the problem for the Earth, but still it's an important, let's say, step. The final step, their, let's say, disposal, is extremely important to preserve space for the future generation, because this is also something we consider space as a global common, and therefore it's extremely important for us that everyone is able to access space now and in the future, right? So we have been talking about mitigation a lot. Sooner or later, we will also need to see how we can clean a little bit. There are a lot of activities ongoing, a lot of discussions. And this is, again, one of the most trendy topics that we discuss in these very days at the UN. And so we are putting a lot of attention on what we call the space debris, and how to mitigate on one side and also prevent for the future that the situation becomes worse.
I was thinking, Simonetta, that I would love to be in your position to have a private use of satellites around the world to control my 4 children, and I would do it like the first day. I would say, guys, if I am the head, I will use the satellites to control my children. And this is I want it in the contract.
Don't tell them, because I'm not sure they will allow you to do so.
Yeah, I will say internally, I will classify that information internally, but I would make it clear inside my contract. I want that rule. That would be really helpful. But I mean, what kind of use has been done or could be done of satellites for like the COVID pandemic, or when there is some kind of dramatic situation like that? How you get involved in that?
Well, we have been affected like all the others. So we went in lockdown here in Vienna on mid-March. And immediately what we have been doing, we have been really working even more than before. And I immediately created a task force internally, and an initiative which is called Space for Health. And we did a webinar collecting a lot of people from around the world, experts, to see how the best practices and already some solutions available based on space-based data could be used for the pandemic phase, but I would say in particular for the recovery phase, because the recovery phase can really be, let's say, space can be instrumental in the recovery phase, because the more we go virtual, the more we let's say, for a bit, we cannot travel. Also teleeducation, training, telemedicine, telesurgery, all these kind of activities can really benefit from space even more than before. But not only. We have a program which is called SPIDER. SPIDER is the acronym. And it's a program that's there since 15 years. And what we do, we provide space-based data and services to everyone, to all the member states of the United Nations, for allowing them to manage the disaster cycle, and in particular the response, the response for in the emergency phase, right? And the more we are able to support member states in this, so in particular in the emergency phase, the more we can try to save lives. But at the same time, we also know that when you have a disaster on top, a pandemic like this case, then the situation is exponential. I mean, the issue is exponential. So combining the two is something that we've been doing. We created a dedicated webpage set of web pages where we collected best practices and lessons learned from a lot of space agencies and other operators. And this is available on our website again. And on top of that, we also started a set of webinars. The first one was just last Monday on space economy, but space economy also looking at the recovery phase after the pandemic. So how space can be even more helpful than before in this, let's say, new normal.
Got it. What do you think are some of the main discoveries or main sectors where you focus that are the most interesting? What do you think are, you know, like the kind of things that you, when you talk with someone that is not working in the space sector, say, all right, well, what is really cool out there that is happening? You say, look, there are these 3 things that are we testing or that will probably happen in the next 10, 20 years and will change everything. Is there something particularly interesting in this moment for you?
Well, you know, when you work in the space field, there are 2 main parts. One is what we call the downstream. So the fact that you develop satellites or you send a spacecraft around the nucleus of a comet, or you land on Titan, or you do things like Titan is the moon of one of the moons of Saturn, or things like that. Well, the advantage of that part is that the advantage, I mean, for the future that I find extremely important is that you have one part of this set of satellites, which is recurrent technology. The technology has been developed in the last decades, and now you get the benefits in the downstream part. So you get the data, and then you develop services and applications for the benefit of the citizens on Earth. The other part is that, for example, if you have, if you land on Titan, or if you explore Mars, or if you build a village on the moon, well, this, or you have astronauts now since decades on the International Space Station, which is this big lab which has been developed by 14 space agencies, or in any case 14 countries. And where you have permanently astronauts.
Lost you for a second. Let me see, Simonetta. I'm sure you'll be back. Oh, there you are. Oh, I can't see you. You are black, like there is like Darth Vader. Is that just reconnect to the link. I'll be waiting for you. Wait. That's very interesting. By the way, guys, just a quick info with Simonetta. We decided to do it in English so that since she works for their UN user, it's possible also for her colleagues to be to understand what we're talking about, and it could be very interesting for you. So let's wait for her, and there you are. There you are.
Back on stage. Okay.
Yes.
Well, no. What I was, so the International Space Station and the astronauts, and the what I see is that the more, I mean, if you have an objective, so if you have a goal which is challenging from for the objectives that this mission or program is. The more you have to develop new technologies, you have to really unleash your creativity, and you collectively, I mean, I'm talking about the space community and all the engineers and scientists and experts, right, all over the world, to be able to reach that goal. And that's the way in which now we have every day, we are using a lot of products which have been derived from technologies developed for the Apollo missions, or from missions which went to Mars in the past, or things like that.
Give me an example.
For example, I don't know, the digital cameras. This is a debate, because there are a lot of people saying, okay, but the digital cameras would have been developed in any case. So why it's a merit of space activities? Well, there was a need to do that So there was put a certain amount of money, a certain, let's say, a set of brains all together, in order to develop what we now use every single day, also with our smartphones, for example, or I don't know, systems to, for example, on the space station, you need to have a closed loop, because you have to recycle whatever, water, the waste and everything. So you can imagine, in terms of sustainability on Earth, how this can be really helpful. And frankly, it was there was the need of spending a lot of public money to develop that kind of technology that now can be very helpful in a moment in which we have overall in the world an increasing number of citizens. So the population is growing, we know. The food and the availability of food is decreasing. The problem that we have with water and also with the land use is huge. And therefore, if you do, for example, if you prepare for a Mars mission, this is an example that I always make. You prepare for a Mars mission. You send humans to Mars. You need to have greenhouses, because you need to develop, to have your plants, your salads, your tomatoes growing, your potatoes, like in The Martian. And at the very end, you need to sustain yourself there. So certain kind of technologies are developed for a trip to Mars, and they have an immediate, let's say, spin-off on Earth, with, I don't know, the vertical greenhouses and vertical agriculture, smart agriculture, or, as I said, how to improve, for example, in terms of sustainability and reuse of waste. This sounds strange, but in the future, this will be more and more applicable to a lot of situations on Earth. Just examples, but I can continue 24 hours. I'm not doing that, but yeah.
Sure. I see. I see. One curiosity about experiments. I was talking with another guest, and he was telling me that I think next year will be done this experiment to simulate how to change the trajectory of a meteor or something like that. That always, we are always worried, and I'm one of them. I'm worried, if something is coming down from the sky, and then will destroy Earth. So is there this kind of experiment out there to do this kind of simulation, or what kind of experiments are out there?
Well, one of the other things we do, we support a team of space agencies and experts. And this team is really doing this. On one side, coordinating potential missions which could help the Earth to survive from the impact with an asteroid. And at the same time, we have another group which is also taking care of eventually how to respond to an emergency linked to a potential impact from an asteroid.
I see.
In terms of communication, in terms of civil protection. In this case, we use our expertise with the SPIDER program, the program I was mentioning on natural disasters, etc., because we have a network of currently 24 regional support offices. These are national offices, mainly are civil protection entities in various countries, and we have this network. So every time we want to send an information for a disaster which is going on, or early warning or things like that, we can activate this network. So the idea is to use the same approach also in case, I hope it will not the case, but in case we are not able to deflect, because the mission you are mentioning is to try to deflect the asteroid from this trajectory, which could be of impact, impacting the Earth. So the idea is to try to deflect the asteroid in a certain manner. But if it doesn't, for whatever reason, doesn't work, then we have to prepare for emergency on Earth. So that's the reason why we have the two groups, and we support both of them.
Got it. But this asteroid deflection is just a simulation. It's not a real danger because there is an asteroid in our direction. I'm already worried now, Simonetta.
Well, having an asteroid on an impact trajectory is rare, but it can happen.
Yeah.
And what we have to do is to monitor all these asteroids, and in particular when they come close in planetary terms to the Earth, so that we can better follow the trajectory thanks to these coordination mechanisms that we have, because they're composed by the main space agencies, so they have tracking systems to be able to check what's happening. The problem is that these asteroids are in principle in their own orbit, so their orbits are not impact in, let's say, it's not in an impact trajectory with the Earth, but due to gravitational fields or small changes in the entire environment in the planetary system, you can have that a small asteroid small itself, but then the impact for a small asteroid on Earth is huge potentially, could change trajectory and could be in what's called impact trajectory with the Earth, which cannot be defined so early. So we need to monitor, we need to see what's happening, and for the time being, we don't expect any big issue, but as usual, prevention is key, and so we are trying to be ready just in case.
Got it. Final question about this, because I see a lot of curiosity. I'm not the only one paranoid about asteroids falling on Earth. Matt DeLuca is asking, how far ahead can you detect an asteroid that is on a trajectory to Earth? Can you catch it really early, or you just look in the sky, say, oh gosh, it's an asteroid coming down, and it's too late?
No. Usually there is time, but as I said, that this is exactly the reason why we have these mechanisms in place. Because if you fail to plan, you plan to fail. That's one of my motto, which means that better you prepare for the worst, and then it could be that you will never use these mechanisms. But better you have the mechanism, better you exchange best practices, better you are prepared with a communication crisis plan. Whatever. This is done in order to be sure that if something happens, we are able to react on time and in order to safeguard humanity. Yes, that's what we want to do, and that's what we are doing. But don't worry, for the time being.
All right. Okay, now I feel a little bit better now, Simonetta.
Yeah,
tell me about the scenarios that we have in front of us. If I chat with my children, like 6 years old and the 11 years old, so the young ones, what should I tell them about space in the next 50 years? Should I tell them, guys, you'll maybe travel to Mars? Should I tell them, no, you will never travel to Mars during your lifetime? Or will you travel in the space because there will be commercial travel available? But what do you think? What would you recommend?
Well, I believe that there is an angle that is always very interesting for kids, but also for us, I would say, as experienced, let's say, individuals. If you look at the Earth is a planet, and is a planet of our solar system. The solar system is, our solar system is in one galaxy, located in one galaxy, which is the Milky Way. The distance between us and the center of the Milky Way, where you have a big black hole, is 25,000 light years, which means that traveling at the speed of light, which is 300,000 kilometers per second, you can reach the center of our galaxy in 25,000 years if you travel at the speed of light.
Right.
And the diameter of our Milky Way, of our galaxy, is 100,000 light years.
Okay.
And this
sounds really, really big.
Yeah, and this is exactly the it's one galaxy among, I mean, billions and billions of galaxies in our universe. Now, if we look at the Earth from Mars, for example, which is not so far away because it's the fourth planet. We are the third and Mars is the fourth, from if we count from the sun, starting from the sun. In reality, you see that the Earth is really a pale blue dot. It's very, very small, and that is where we are.
Right.
So on one side, we are on Earth, but we are part of our solar system. So going to the moon or going to Mars is the next logical step for humanity, from my standpoint. But at the same time, in reality, it's also true that we are a pale blue dot. We are very small in all of this that I just described. So if we look at this from this angle, this standpoint, a lot of small issues that you encounter every day disappear because you understand the bigger picture. And the bigger picture is really big, probably beyond our ability with our minds to understand all the details. And that's the reason why science is so interesting, because the more you discover, the more you have to discover. And in fact, when I was a kid, what I wanted to do was a job. What I wanted to avoid, I wanted a job allowing me to learn every day. Because, you learn, you go to school, you go to university, and then you get a job. And then you learn a little bit every day, but not like I wanted to maintain, let's say, my rate of incremental knowledge. And frankly, I succeeded on that because I'm really privileged in this. And I believe that if you look at the Earth with these eyes, your life by definition will be better because you don't get yourself involved in small things.
Small issues. I still don't understand if I can say to my kids that they will maybe one day travel to Mars or not. Is it something that you...
yeah, absolutely, they have to.
Right. But do you think that we are like still at the ice age of that kind of thing? Or because sometimes you can hear Elon Musk or other people talking, and they look kind of confident to say, 30 years and we'll send some people to Mars. Yeah. And you think, wow, is it real? Is it just a marketing stunt?
No, it's real.
All right. So the technology is getting there.
I mean, it's a question of technologies. It's a question of investments. And it's feasible with the current technologies we have. And Elon Musk is trying to reduce. One of the issues is that currently, the two planets are in a position, one with respect to the other, which allows a launch from Earth to Mars every 26 months. In fact, this year, in just few days, the launch window will open for more or less 2 weeks. And so you will have the Chinese, the UAE, the Americans. They will launch their mission to Mars. So the question could be why they're launching all at the same time. Well, it's easy because you have just 2 weeks launch window every 26 months between the Earth and Mars. It's celestial mechanics, so you cannot do anything. However, this is because we have a certain technology which allows us to go to a certain speed towards Mars. And then it's a question of, which kind of dynamic for the trajectories you select, depending on the mission you have. But more or less, you need between 6 and 7 months, let's say, between 6 and 8 months to go to Mars, from Earth to Mars. Then at that point, if you send humans on Mars, then you have to wait until the planet is in the right position with respect to Earth to come back. So it's about 1.5 years. And then you have another 6-8 months to come back. So currently, a mission to Mars, back and forth, it takes 2.5 years, more or less. Okay. What Elon Musk is trying to do is to shrink the time to go from the Earth to Mars. And in that manner, you can spend, for example, just a few weeks on Mars and then still come back.
I see.
With the new technology, you can do it. So the trip will be around 7-8 months. Okay.
Oh, easy. 7-8 months, easy.
Easy. In addition to that, in reality, the more you increase the speed, the more you can do back and forth. So it's a question of technology, how you can then deploy your mission. The idea that Elon Musk has with Starship is to really bring to Mars 100 people. At least this is the design. And he's testing for the time being the spacecraft. Not clear, however, how he will bring back these people.
Yeah.
So it's more for the time being a sort of developing an outpost, and let's say a place where then
that's
you can
a secondary
live
question, Simonetta. I mean, if they come back or not, we'll see. We'll decide it later.
To be very honest with you, going there, I would like to come back, but that's no perspective.
Right. That's very interesting. So is not so science fiction as sometimes some people say. So we get in there basically. That's the direct. And what about the moon? I saw it in the chat. Final question, then I'll let you go. That there is some people was curious to understand why we're not doing more on the moon. Why don't we have like a city on the moon, or moon is already boring and we need to go somewhere else? What's the situation with the moon? We're not the owner of the moon. That's we already understood.
Yeah, that's for sure. No, okay. So there are a lot of missions ongoing. The Chinese, the Indians, the Europeans, the Americans in particular right now. The Chinese are already there with a set of missions. They're called Chang'e. And I believe they are Chang'e 4 on the moon and preparing for Chang'e 5. And Chang'e 5 probably is the mission which is bringing back some samples from the moon. And for the time being, all of these missions are robotic, which means that they have rovers and other robotic, let's say, tools, but no humans for the time being. Instead, NASA is now working with under the umbrella of the Artemis mission, with the idea of sending 2 astronauts, American, and the first one man and one woman, back to the moon, landing on the moon on 2024. That's the target. Right. On 2024, they should be able to land back. The moon is easier in terms of quote unquote, better Mars, because with the moon you don't have the same restrictions in terms of launch window. And so they are testing several systems, and they should be able to land by 2024 on the moon. Well, clearly at that stage, they're already trying to bring other countries in this endeavor to develop, a village, call it a village, or in any case,
a Disneyland theme park.
Yeah, I know. But then you need plants, you need power plants, you need a facility to bring back people, so a launching facility. So there are a lot of then the crew quarters. It's not. You have to build a village. Yes. So a sort of a self-sustained village, and this will be done also with the collaboration of a lot of other countries.
You said, Simonetta, that on your website it's possible to check the list of all the satellites that are out there in the space. But what about all these missions from all the countries? Are all classified information? There are websites where you can get information about what's going on with the different missions, what they're doing out there, or is just top secret? That's it, and.
Well, that's exactly what we do. Also with the Committee on the Peaceful Uses of Outer Space, usually we have a few days at the very beginning every year where all the member states report on the status of their activities. We collect all this information, we distribute the information. Again, what we do is really trying to improve transparency and to improve the confidence. I mean, the credibility also what they do. Also we have also a lot of bilateral cooperations with these countries: China, Russia, United States, Europe, India, South Korea, New Zealand, you name them. And on a regular basis, we do some joint activities where we present some joint events where we present these activities. And because, you know, it's also a question of best practices and lessons learned that others can benefit from. So it's quite open, the information of what's going on.
Got it. Very good. Simonetta, it was really, really interesting. And congrats again for everything you're doing. And I'll try to go deeper into the annual report, the 88 pages. I think I'll finish for 2024 when I will be on the moon.
So it's a message. Next time I have to shorten it. I guess.
Yeah. But really, really interesting. Also, Space for Women, I saw a lot of activities there. Yeah. So that's also very, very, I think, very important, very, very good. And yeah, let me know if you like the continuous Space Force episodes. Let me know if you enjoyed that.
I'll do that. Now I have to do it. I have to watch it. Yeah.
Great. Thank you so much. See you soon.